One of these photos gives us the oldest glimpse of the universe. We can see 13.1 billion years into the past. In another, we discovered an alien exoplanet where water, H2O, has been found. Come, let's try to understand these new discoveries in today's videos. The James Webb Space Telescope is the largest and most powerful space science telescope ever built. Friends, this telescope cost about $10 billion. It took NASA 25 years to work out its design and development. And most interestingly, the spot where this telescope is located currently, it is operating at the temperature of 266.75 degrees centigrade. It is so cold that it is almost at the absolute zero temperature of 273 degree. Temperature cannot fall beyond that. It is only a few degrees warmer than that. To maintain this temperature, the James Webb Space Telescope doesn't orbit around Earth like the Hubble Space Telescope. Rather, it orbits around the Sun, about 1.5 million km from Earth. There's a point known as the L2 point. It is always in the Earth's shadow, in a way that it can safely orbit the Sun. As you can see in this video, to block out the rest of sunlight, a sun shield has been attached behind it. It's nearly as big as a tennis court. Do you know what is the focal length of this telescope? Those of you who use DSLR cameras as a hobby would know the lens of those cameras usually has the focal length somewhere around 24 m, 35 m, or 50 m. The focal length of the James Webb Space Telescope is more than 2,500 times of it, 131.4 meters. Meters, not millimeters. Its main mirror weighs around 705 kg. I have discussed these technical aspects. Let's get straight to the point and talk about the photos taken by this telescope. Before this, let me remind you that this is our electromagnetic spectrum. Different EM waves have different wavelengths. In it, there is a tiny spectrum of visible light, the light which we can see with our naked eyes. The rainbow colors: violet, indigo, blue, green, yellow, orange, and red. This wavelength ranges from 0.38 to 0.7 micrometer. Wavelengths higher than red are known as infrared, and the wavelength on which this James Webb Space Telescope can take pictures in ranges from 0.6 to 28 micrometers. There is a small overlap with the visible light, but mainly this telescope works with the infrared portion. You can look through the gases and clouds because of the larger wavelength of the infrared light. The longer the wavelength, the easier it is to go through objects, such as radio waves, whose wavelength is measured in kilometers. We can listen to them through the radio. Those waves can travel through our homes and walls. 2 infrared cameras are mounted on this telescope. The near-infrared camera, NIRCam, to capture the shorter infrared wavelengths, and the mid-infrared instrument to capture the longer infrared wavelengths. Depending on the camera used by the telescope, the photos vary. Look at this photo. This photo taken by the NIRCam, truly breathtaking. It went viral on social media when the photos were released by NASA. But the same photo was taken by the MIRCam as well. And the same thing looks like this on MIRCam. The dust clouds which were visible don't show up much on the MIRCam because the wavelength captured by MIRCam is longer, so it is easy for it to pass through objects, enabling us to look through the clouds. You might ask now, what is the thing in the photo? What are we looking at? Friends, the answer to it is we are seeing the death of a star. Yup, that's correct. We can see the star die. There are 2 stars in this photo orbiting around each other. The brighter star of the 2 is at the early stages of its life, and the dim star is dying. While dying, over the last thousands of years, this star has been releasing clouds of gases and dust. The cloud of the gases and dust is known as the planetary nebula, and because the 2 stars are orbiting each other, the cloud keeps getting swished around, similar to how you mix sugar into the water because of the gravitational pull of both stars. This is the shape of the cloud. It is interesting to note that in the NIRCam photo, you can see only 1 star, and you can see the cloud clearly. But in the MIRCam photo, the cloud is quite muted, and you can clearly see the 2 stars. As I explained, because of the longer wavelength, we can see the center of the dense cloud. If this is the first time you're hearing about stars dying, shocking, isn't it? I'd like to tell you that similar to the life cycle of humans, childhood, teenage, adulthood, old age, and then death, similarly, stars have a life cycle too. Our sun is a star as well. It is quite young now. About 5 billion years later, our sun will become a red giant. After becoming a red giant, it too will go through the same stages that these stars are going through in this photo. It'll become a planetary nebula, after which it'll be a white dwarf, and then the end. Red giants are bigger in size than an average star. When our sun will turn into a red giant, it will swallow the planets of Venus and Mercury, and Earth will no longer have living conditions. But do not worry, humans have 5 billion years to discover some technology which can push back Earth's orbit. But that's for later. There's no use talking about it now. Let's talk about the rest of the photos. The first photo released by NASA was this one. It is perhaps the most historic photo too. This photo gives you a glimpse from 13 billion years ago. After seeing this photo, American President Joe Biden said that it is a new window into the history of the universe. In this photo, we can basically see a galaxy cluster, SMACS 723. The galaxies closer to our camera have a high gravitational force such that they are distorting the light coming behind them. It creates a magnifying glass of sorts. This phenomenon has been named gravitational lensing. With its help, we can see objects behind it. It isn't a photo which was simply clicked by the telescope as is, similar to how you point your camera, tap a button, and take the picture. It's not so. It took 12.5 hours to take this photo. Actually, the telescope had to take several different images at different wavelengths, and later combined them. And we're now seeing this combined photo. In it, the galaxies that appear redder in color are farther from us. The redder the galaxy, the farther it is. While we're discussing the distance, look at the next photo. This has been named Stephan's Quintet. It is a cluster of 5 galaxies, and the prefix quin is used for the number 5, such as quad is used for 4. This quintet is more of a quadet, because the leftmost galaxy among them are 40 million light-years away from us, and the other 4 galaxies are about 290 million light-years away. As you can see, the photo of the leftmost galaxy looks more HD if you zoom into this photo, while the other 4 galaxies look quite blurred. These 4 galaxies are so close to each other that the dust and stars present in them have started interacting with each other. We can see the effect of their gravitational forces on one another. For scientists, this is immensely interesting to see. The scientists want to know what happens when galaxies get so close to one another. Next is the most beautiful photo till now. In it, we can see the birth of a star. After seeing the death of a star, we can now witness the birth of a star. We will discuss now the birth of a star in our next video. I hope this video was as informative as always. If you like this, subscribe to this channel and go watch the other videos as well. Let's meet in the next video.